Let us start with the COCOMO model. So first, what is a COCOMO model, right? So COCOMO model means it is a constructive cost model, right? It's also called as constructive cost model, right? Constructive cost model. What is the use of it? So it is used for calculating the effort, development time, staff size, and productivity. Right? So calculating the effort. So what do you mean by effort actually? So effort means for completing a particular project, how much months it will take, how much months it will take for a person. Right? So what do you mean by effort? So effort means for a particular project, only one person is actually doing that project. Just take an example. Only one person is doing a project. Okay. So that person, how much time he is taking the project to complete. Right. So in person, months. That is what you call as effort. Then what is the development time? How much time it is taking for a particular project to be completed. So the development time, right? And average staff size. At least for an average, how many staffs is required for the project, and the productivity, right? So these, what is that? Values will be calculated using the constructive cost model. Why are you calculating all these things? To calculate the cost for a particular project, right? To calculate the cost for the particular project. So COCOMO model is basically for calculating the cost of it. How you are calculating the cost? With the help of these parameters. What are the parameters? Effort, development time, average staff size, and productivity, right? So COCOMO means what? It is constructive cost model. Fine. So now let us see. What are the different levels of COCOMO models? There are 3 levels. Okay, so the first one is the basic model, then intermediate model, right, and then detailed model. So these are the 3 levels or hierarchy of COCOMO model. So let us discuss one by one in detail, right? This was developed by whom? B.W. Boeing, right? So we'll be discussing each models one by one. So each models you can expect mathematical questions or say sums, right? They will be asking some mathematical questions. So let us discuss few examples also if possible, right? But let us start with the basic model. So what is a basic model, right? So this model aims at estimating in a quick and rough manner, right? Most of the small to medium-sized software project. Small to medium-sized software project. You may be asking, sir, how to identify this is a small software project, this is a medium software project? It's very simple. COCOMO model is based on lines of code. It is based on lines of code. If the number of lines of code is say less, it is called as a small software project. If it is say a considerable number of lines of code, means it is a medium size. Likewise, it has been categorized, right, with the help of lines of codes. Okay, so 3 modes of software developments are considered in the model, right? 3 modes of software. One is organic, semi-detached, and embedded. Let us see what do you mean by semi-organic, what do you mean by semi-detached, and what do you mean by embedded, right? So 3 modes are there, right? 3 modes are there in the basic model: organic, semi-detached, and embedded. What do you mean by organic? How it is actually categorized? So organic means typically the project size will be 2 to 50 kilo lines of code. Kilo means what? 1,000, right? So 2 kilo means 2,000, right? So 50 kilo means 50,000. So 2 to 50,000 lines of code is the project size. So this you can call it as organic mode. So how the nature of the project is? The nature of the project is small sized project, right? Experienced developers in the familiar environment. They'll be having some experienced developers in the familiar environment. For example, payroll, inventory projects, right? So all these are, you may have already done it. You need to have some slight changes in that project and you can deliver it. Because you have the basic code, based on the client requirements, right? You can remove the features or you can add few features and you can deliver it. That is why it is called as the small size projects or organic project, which is already available. Okay, right? So what is the size is 2 to 50 kilo lines of code, right? And innovation, there won't be much innovation because already you have the modules, right? So you can directly use that modules and you can add some features and deliver it. That is why it is called as organic. So innovation will be not much; it will be very little. Innovation will be very little. And deadline of the project is not tight. It won't be tight because they'll be asking the client for say 1 month, right? But you can able to complete the project in say 1 or 2 days or maybe 10 days, and the remaining 20 days we can be free. So in that case, the deadline of the project is not tight. Okay, and development environment familiar and in-house because everything is available in your hand, right? So it is familiar. So all the codes are familiar, right? So it is the development environment is familiar and it will be in-house only. No need to outsource it. No need to outsource it. Every code, everything you can done it in-house manner. That is why it is called as an organic mode. Okay. The next is semi-detached mode. So in semi-detached mode, the project size will be 50 to 300 kilo lines of code, right? 50 to 300 kilo lines of code. So what is the nature of the project? It is a medium-sized project, right? Again, medium-sized team, average previous experience on similar project, right? For example, utility systems like compilers, database systems, editors. Okay, so these kind of projects we can call it as the semi-detached because few things, few concepts, few features, right? Few modules are already available. You may have available, but few things are you have to develop it. Few things you have to develop it. So the nature of the project, right, will be semi-detached or it will be a medium-sized project, right? And innovation will be medium, right? Few things you have to do the innovation. Deadline of the project also it is medium, and development environment is also medium, right? And in embedded, the typically lines of codes will be 300 kilo lines of codes, above 300 kilo lines of code, right? So typically over 300 kilo lines of code. So it will be a large project, and you have to deploy the project in the real-time systems, like say ATM machine. You have the ATM machine, and your software should work in that ATM machine, right? That is why it is a real-time project, right? Air traffic control is another example, right? Air traffic control also you have to deploy the project, I mean the software into the particular air traffic control system. So that is also a real-time systems, right? It is a real-time system. So it is called as an embedded programming. So it is innovation significant. You have to think a lot. You have to say, you have to match it with the real-time environment, right? So this innovation will be significant, right? And deadline will be also tight. It will be complex. Hardware will be there, and customer interface is also required, right? Customer interface is also required. This is your embedded one. So 3 modes we have discussed: organic, semi-detached, and embedded, right? Fine. Okay. So now the previous case, right? We have discussed about the explanation or what is the meaning of organic mode, what is the meaning of semi-detached mode, what is the meaning of embedded mode. With the help of this information, what the researchers have done, right? They have come to a formula, right? Based on the formula, the effort, development time, all these things we can able to calculate, right? So for that they have developed or they have created an equation, right? The basic COCOMO equation take the form E. What is E? E is the effort is equal to A into kilo lines of code raised to B, right? K into, kilo lines of code, A into kilo lines of code raised to B, right? And for D, what do you mean by D? D is the development time, right? So D is equal to C into E. what is E? E is a effort taken, right? E is a effort taken. What is that? And to the rise D, right? So C into E raised to D, right? So here A, B, C, and D, all these four are called as coefficients. It's a constant value, right? It's a constant value. How they have attained this? With the previous experience, right? With the previous experience, they have created an average value or a constant value, which is called as the coefficients. AB is a coefficient, BB is a coefficient, CB and DB is a coefficient, right? So for each and every mode, for each and every project mode, right? Organic, semi-detached, and embedded, they have created a default values, right? Okay, fine. So from this, we can able to calculate the effort of it, right? So let us see. And also we have to calculate the average staff size, right? Average staff size and productivity. So for average staff size, right? E divided by D. What is E? Effort. What is D? Development time. Okay. Fine. And productivity, how to calculate? Kilo lines of code divided by effort. Okay. Fine. Okay. So let us calculate that in detail, right? So example problem is there, right? A small mistake I made here. 539.71, right? Okay. So now let us see the example here or a problem. Suppose a project was estimated to be 400 kilo lines of code. So 400 kilo lines of code. So let us see what is there in the 400 kilo lines of code means it is, say it will be coming under semi-detached. Okay. Calculate the effort and development time. Calculate the effort and development time for each of the three modes. They are asking for all the three modes, right? Organic, semi-detached, and embedded. They are asking for all the three modes. They haven't worried about the number of lines. So let us see how to calculate it. So 400 kilo lines of code, right? Fine. So now I have calculated it for organic. The remaining things you please calculate in your home, right? So consider this as homework and please calculate it. Okay. So they have given the size of the project. What is the size of the project? 400 kilo lines per code. Okay. Now we can able to calculate the effort. So what is E? So E here is what? A into kilo lines of code of B. What is A here? Right. So A here is 2.4. What is B here? 1.05. So that is why I have shown here A is 2.4 and B is 1.05. When I'm calculating this, this is 539.71. What is this 539? How can you explain this 539.71? That is in person months, right? That is for this 400 kilo lines of code project, size of the project, right? If one person is doing this project, he will take 539.71 months, right? 539.71 months, right? One person will be taking this many number of months to complete the project. This is the meaning of the effort, right? This is the effort, okay? Now, what will be development time? Then development time is equal to C into, what is that? E raised to B, right? C into E raised to D, right? So C, what is C here in organic? 2.5. What is D here in organic? 0.38. So 2.5 into E raised to, what is that? 0.38. Now what is the value? Let us see, right? So let us take the calculator, right? So go to the calculator, take the scientific one. Normally it will be standard one. Go to the scientific one, right? And 2.5 into, what is that? 539.71, right? Raised to 0.38. So 27.29, right? 27.3, for example, right? 27.3. What do you mean by this 27.3? What is this 27.3? So the result we are getting is 27.3. So it means that development time will be 27.3 months, right? 27.3 months, right? To complete the project. Okay. So this is the effort, and this is your coefficient, okay? And it will take 27.3 months to complete the project. So from these two values, effort and development time, can we able to identify the average staff size? Yes. How to identify it? With the help of E divided by D. What is E here? Effort. What is D here? Development time. So here, what is the effort? 539.71, and what is the development time? That is 27.31, right? So if we calculate this, we'll be able to identify the average staff size. Let us see what is the value. 539.71 divided by 27.3. So you will get 19.76. Say 19.77. So 19.77. So how many average staff size will be there? Say 20 staff size. If you have 20 staff, you will be able to complete the project in this particular time. 27.3 months. Within 27.3 months, you will be able to complete the project with the average staff size. How many? 20. So 19.77 means round it off. Approximately 20, right? Approximately it is 20. Okay. With the help of 20 staffs, we can complete the project in 27.3 months, right? And the effort will be 539.71, right? This is your, likewise, you can calculate for what? You can calculate for semi-detached, and embedded, right? For these three things, you can able to calculate. So please calculate. So I think it's very simple to calculate because they have given the value directly. Okay. So let us discuss another example. A project size of 200 kilolines of code is to be developed. So 200 kilolines of code is to be developed. Software development team has an average experience on similar projects, right? So the project schedule is not very tight. Calculate the effort, development time, and average staff size and productivity of the project. So first, let us see the project size. So project size in the sense what? So project size is 200 kilo lines of code. So this will be coming under semi-detached, right? Semi-detached. And what is that? And it is not tight. They have mentioned that the product schedule is not very tight. It is in the medium one, right? And what they're asking is, they're asking that the effort, they're asking to calculate the effort, development time, average staff size, and productivity of it. So here, very simple. This is a semi-detached software project. So you have to take these values, right? You have to take these values, right? Semi-detached values. So please try it in your home, right? And you can calculate the effort, development time, average staff size, and productivity of the project. Like this, we have calculated, right? Likewise, you have to calculate for this particular example also. Okay. Okay. I hope you have understood. So can I move on to the next one? Okay. Thank you. Right. So the next, we have discussed up till now what? Basic model, right? So now we are going to discuss about intermediate model. So intermediate model is also exactly similar to the basic model, but they have added a parameter, right? They have added a parameter that is EAF, right? EAF. What is EAF? Effort adjustment factor. They have added an effort adjustment factor. Let us see in detail. Don't worry. So intermediate model. So to improve the accuracy, 15 cost drives were introduced. This is what we call as the intermediate model, right? So 15 cost drives. What is that cost drives, right? So there are, they have categorized the cost drives into four types, four categories, right? Product attributes, computer attributes, personal attributes, and project attributes, right? So all these four categories they have grouped for calculating the cost drives, right? So to improve the accuracy, so in the basic model they haven't taken any what is that? They have an accuracy, but to improve that accuracy, they have introduced 15 cost drives. What is a cost drives? Cost drives are used to adjust the nominal cost of a project to actual project environment, right? So they are converting the nominal cost of the project to actual project environment, right? So this is your cost drivers. So what are those cost drivers? So if you are including these cost drivers, what happens, right? You can able to increase the accuracy of the estimate. The cost estimation accuracy can be increased. So what are those cost drivers? Let us see in detail one by one. Product attributes. So for the product attributes, they have taken three main cost drives: required software reliability, database size, product complexity, right? So required software reliability. So how many say years or how many months the project will be, or the software product will be used, right? After that, it will be thrown off sometimes, right? So the required software reliability, how many days or how many months or how many years the product has to what is that continue to work, right? So it is mentioned in the short form as RELY, RELY, required, RELY, right? Required software reliability. Then database size. What is the size of the database? Okay. And then product complexity, right? CPLX. You may be asking, sir, what is the short form? Why they are making it as a short form, right? Just to easily understand what is the meaning of RELY, right? Don't worry about this short form, right? Just understand what is the meaning of these attributes, okay? The next attribute, sorry, the third attribute is product complexity. What is the complexity of the product, right? So these three attributes are taken under product attributes. Then the next one is computer attributes. So execution time constraint. So how much time the software is going to execute, right? So the execution time constraint, storage constraint, right? Main storage constraint, and virtual machine volatility, right? And computer turnaround time, right? So these four things are actually taken under the computer attributes. So likewise for personal attributes, analyst capability, application experience, programmer capability, and virtual machine experience. So all these are under personal attributes. And project attributes, modern programming practices, right? Use of software tools, required development schedule. So all these come under project attributes. So these attributes are taken into account, right? So what actually they're doing in each attribute, so they have again given a constant value based on the previous project experience, right? See here, the ratings are given for each attributes. The ratings are, say, for project attributes, what is that? Required software reliability, that is what RELY. Required software reliability, the ratings is very low, 0.75, right? Low means this one, nominal means one, high means this one, very high means this one, extra high means this one, right? So these are the average values. These are the values of it, okay? 0.75 to, say, 1.40. This is the ratings they have given, right? And for data, these are the values. For complex, right, these are the values. For time, these are the values. Likewise, they have given the values of it. So each cost driver is rated for a given project environment, right? For a given project environment, okay? So likewise, for all the other attributes, the value is given. So the effort adjustment factor, ranges from 0.9 to 1.4, right? 0.9 to 1.4, right? So how that 0.9 they have calculated, right? Taking all these values, taking all these project attributes values, right? And they have taken the average of it, right? So starting from 0.9 to extra high, right? So they're taking all these values and they have averaged it. So 0.9 to 1.4 is the effort adjustment factor, right? So these are the range of these values, right? Typically, it will be ranging from 0.9 to 1.4, okay? Mostly in the problems in the examination, right? They will give the EAF values, right? EAF average value will be given directly. For example, say the effort adjustment factor will be 0.10 or 0.11. So likewise, they will give the value of it, or else you won't be able to identify these values because these number of values they have to give in the questions. So it won't happen. So normally what they will do is that they will give the EF values, right? The intermediate COCOMO equation takes the following form. The same equation of the effort which we discussed in the basic model. What is the only change? You are multiplying with EAF. What is EAF? Effort adjustment factor, right? Fine. And then D will be same. The development time will be same, right? And these values are same as the basic model, organic, semi-detached, and embedded. All these are same values. Some few changes will be there, I think. Yes. So here in this case, 2.4 is there, right? In organic, 2.4 is there. But here the values will be 3.2. Yes, slight changes are there. So for this, you have to use these values in the, now what is that, intermediate model, okay? So these are the coefficients for A, B, C, and D, right? So from this, you can able to identify the effort and what is that, development time, okay? And you may be asking, sir, what is the formula for, what is that? Formula for average staff size, the same formula. Productivity, the same formula, right? So everything is same. The only difference is your effort adjustment factor. The effort adjustment factor, you have to multiply with the value of this. So you'll be getting the effort, okay? This is the only change in the intermediate model equation. Another change is your values of project mode, organic, semi-detached, and embedded. Slight changes are there, and also these values are also new, right? This is the difference between basic and intermediate model, right? The third one is detailed model. Detailed model, as I already told, it is having more number of what is that lines of code, right? So in this case, the detailed model introduces two more capabilities. What are those? Phase sensitive effort multipliers. So for each phase, they are calculating the effort for each phase, design phase, programming phase, integration phase, testing phase, right? So for each phases, effort multiplication is, effort calculation is done. Okay. Phase sensitive effort multipliers are there. That is, some phases are more affected than others by factors defined by the cost drivers. The detailed model provides a set of phase sensitive multiplier for each drivers, right? So it is providing a set of phase sensitive multiplier. So each phase is having its own sensitivity values. Okay, so that will affect the effort and the cost also. Okay, this is your phase sensitive effort multipliers. And then 3-level product hierarchy, that is module, subsystem, and system level. So module level, subsystem level, and system level, right? So the cost driver also done in module level, system level, and subsystem level, right? So the detailed model introduces two more capabilities. What are those? Phase sensitive effort multipliers and 3-level product hierarchy. Based on this, they are calculating the cost. Okay. So as I already mentioned, right, the phase sensitive effort multipliers, right? Here in plan or requirement phase, this phase consumes 6 to 8% of the effort. You'll be calculating the effort with the help of the formula, right? From that, you can able to divide. That is, you can able to identify that is 6% to 8% of the effort can be taken for planning or requirement phase. Okay, and 10 to 40% for the development time. Okay, so for this plan and requirement, how much effort, how much development time, right? For the product design, how much effort and how much development time. So what is the effort for the product design? 16% to 18%. And product design development time is 19% to 38%. So likewise for each phases, programming phase, integration phase, for each phases, right? They have calculated the percentage of the effort. Okay, so 48%, 68%, all these things are there, right? Fine. So how to calculate the effort and what is that development time? So here the formula changes. So E is equal to mu into E, and D is equal to I into D. What is mu and what is I? Right. So these mu values are categorized into different what is that project size, right? Project mode or project size. First one is organic small, right? And organic medium, semi-detached medium, semi-detached large, embedded large, embedded extra large. Likewise, the category. See, organic mode is categorized into two parts. One is organic small and organic medium. Semi-detached is categorized into two parts. What is semi-detached medium and semi-detached large? Embedded is converted into two parts: embedded large and embedded extra. So each is having its own percentage. For example, say plan and requirements 0.06 is the default value. System design 0.16. Detailed design 0.26. Module code and test 0.42. Integration and testing is 0.16. Likewise, they have given the values. There is the mu values. Then what is the I values? That is for the development time, right? So I values, likewise, it is categorized into 6, right? So and correspondingly, you are having the values. So based on this, you can able to calculate the effort and development time, right? Fine. So these are the three what is that hierarchy of model? What are those? Basic, intermediate, and development time.